Okay, so welcome back to sensors and actuators. So this will time it will be part 3. Okay, so we go now to Arduino starters. Okay, so we're done with this breadboard, this blink, fade, this button. Okay, the analog input, read serial, the servo. Okay, so this time we're gonna use this ultrasonic range finder, or it's gonna measure distance, no? Distance range. Okay, so you notice that it seems the circle is like an eye. Okay, but actually this three terminal or three pins ultrasonic sensor is a microphone and speaker, no? Because the speaker will generate the ultrasonic sound that is 50 kilohertz above, and the microphone will receive, no, will receive the reflected sound, ultrasonic sound. Considering that in front of this ultrasonic sensor is there will be an obstacle, it could be a wall, or you could be your hands, no, covering the ultrasonic sensor. Okay, so the principle is the same as the sonar. Okay, sound, navigation, and ranging. Okay, it will sense distance, of the obstacle of the object. Okay, so there are three terminals. The ground is connected to the ground. The 5 volts is connected to the 5 volts. Okay, then the signal is connected to pin 7. Okay, so there is also another four terminal or 4 pin ultrasonic sensor. Okay, so right here. This time the trigger and the echo pin is separated. Okay, of course they have the VCC and the ground. Okay, so we're gonna rotate this one. Okay, so we're gonna connect it later. Okay, so let's try to analyze the code. Okay, change this to text. Okay, zoom. Okay, so you have here. Okay, you have here global variables, no? Integer for the inches and integer for the centimeter. Okay, so you have here a declared uh, function. So with a return data type of long. Okay, so it says here the name of the function is read ultrasonic distance. Okay, with two arguments or parameters. The first one is the trigger pin, and the second argument or parameter is the echo pin. Now, in part in this function, okay, is the pin mode declaration. Okay, the trigger pin as the output. Okay, then the same time, since we're using the same terminal for the trigger pin and the echo pin, so that's why uh, it's possible that you declare here the pin mode for the pin echo pin as input. Okay, from output can change to input. Now the reason for output it's because it will be using the speaker function of your ultrasonic sensor. If you're going to look this circle, it's actually speaker in reality. Okay, then for the initialization, the speaker or the trigger pin will have low. signal first, then it's a part of the initialization. So with a delay, take note it's in microseconds. Delay microseconds or two microseconds. Then after 2 microseconds, it's the time that the ultrasonic speaker will transmit an ultrasonic signal through its trigger pin. So it should be high. Okay. Then it will be for 10 microseconds. So therefore, the pulse generated has a pulse width of 10 microseconds. Okay. After the 10 microseconds, then it will be triggered low. So it's just generating a ping. Ping. Okay. But except that you cannot hear the ping because it's above 50 kilohertz. Okay. So only the dogs and cats perhaps can hear the ping. Then you convert now the same functionality of the ultrasonic sensor into a microphone. So that's why you need this echo pin to be acted as or in mode input mode. Okay, so if you're going to read the command here, reads the echo pin and returns the sound wave travel time in microseconds. Okay, so it's 10 to the minus 6 seconds. Actually, that function is what is known as pulse in. Okay, of course, you need to place here the pin, the input pin, which is the echo pin. So echo is also known as the reflected sound. It's the bouncing sound. Okay, it will detect the pulse, the pulse. It should be high. Considering that this is in time, the function is returning in time. So later, we'll be estimating the constant, how to compute distance. If you're able to determine the travel time, okay, you can always compute for the distance. Okay, so in the setup, we're using the serial communication 9600 baud rate. Okay, here is now the computation for the distance. No? So we just simply multiply it by the constant 0.01723. But the question is, how did we came up with this value or constant? So take note in centimeter. Okay, so the speed of sound is 343 meters per second. But since uh, it's going to travel, forward and then forward travel, then the reflected travel. Okay, so just simply divide the time by 2 because it's actually the time measured, uh, using the pulse in input is twice, double the time because it's the forward direction of the sound and reflected back. So that is the reverse distance. No, so the time is twice. So therefore, you need to divide this by 2, considering that the formula for uh, the distance is speed times time. So if you have 343 meters per second times time, so the time you divide it by 2. So that is around 170 plus, okay, or 171.5, okay. Then since the time is expressed in microseconds, so you divide it by 1 million. Then since this is in meters per second, then you multiply it by 100 to make it centimeter. Okay, so but anyway, you can always do your computation. So as a result, it's actually 0.017. Okay, so the 0.23 is actually part of the calibration of the your transducer or your device. But anyway, you could always update this value, this constant, based on actual measurement. Okay, so centimeter now is equal to this constant as explained, multiplied by the pulse in. Okay, this one, that is the return value, which is also actually the part of the function read ultrasonic distance. Take note, the first parameter is the trigger pin and the echo pin. So since they are connected on both 7, pin 7, so that's why you write there 7, 7. Then converting it to inches, case, so 2.54 centimeters actually one equal to 1 inch. Okay, so that's why you need to divide. Then using the serial communication, you need to print. Okay, do not forget this delay 100 milliseconds. It's very important. Okay, for the simulation to work. Okay, so let's start to simulate. Okay, so you notice that this ultrasonic now is turned on. Okay, so let's include as well the serial monitor. Okay, what's nice about this simulation is it has this acceptance cone, uh, simulated acceptance cone. So this is the typical range acceptance cone of the ultrasonic. So okay, so the obstacle now read is around 44.4 centimeters. Okay, so in the serial here, it's also the same. For the inches, it's 17.5. Now, the reason that it's not displaying the decimal places, it's because uh, we are using integers. No? So, might as well change this to float. Okay, you're interested for the decimal place. Actually, it's better to have it in inches, in integer long. So, let's now play this one. Okay, so there you go. So it's now registering almost the same 17.5, okay, then 44.4. Okay, so that's a disadvantage of floating point operations. It requires higher CPU usage because of its complexity and the computation. So if you want your Sonic to be faster, then you might as well consider integer. Okay, so stop simulation. We're gonna wire the four. Okay, so this is the BCC. It must be the four terminal ultrasonic sensor must be connected to 5 volts, and it must be read. By the way, nowadays this is the four terminal that is more common than the three terminal. Okay, then this must be ground. Okay, and this must be black. Now, oh no, black. Now let us say the trigger pin. We're gonna connect it uh, near the coin. So 7. Then this time it's 8. So we're gonna color it to yellow. Oh no, it's the trigger pin. Okay. Then the echo pin. We're gonna connect it on the 9. Right. Okay. So we need to change the program so that we could use this. Okay. Okay. So changing here, this becomes 8. For the trigger pin, and the echo pin is 9. Okay, so 8 and 9. Okay, so we're gonna play. Okay, click this part. Okay, click this part. So it's registering 44.7 and 113.4 centimeter. Now let's make it closer. Okay, so in principle, this four terminal or four pin echo ultrasonic sensor is faster considering that it has dependent trigger and echo pins unlike the three terminal, and it's an old technology. Okay, so our next topic is we're gonna integrate. Okay, we're gonna integrate the two. Okay, the two ultrasonic. Okay, with the LCD. Okay, so we're gonna integrate it with the LCD. Okay, so actually, we just simply insert the codes from the existing LCD codes. Okay, so let's try to analyze the code here. So actually, this is the LCD code. Okay, and we simply insert it. Okay, we simply inserted the the inches and the centimeter variables here on top, and we inserted as well the serial communication here below the LCD print in the setup function. And note that the read ultrasonic distance must be on top no, code of the LCD. Okay, so in here we copied the same formula, then we divide it by 2.54. Okay, so we try it with the 3 pin ultrasonic sensor. Then always remember that there must be a delay 100 milliseconds. Okay, so it will work. Okay, for the LCD, we have here for the centimeter and inches. For the serial communication as well, we have here. Okay, so click this. Okay, so let's start simulating. Okay, sorry. So it's using this one. Okay, so it's 13. Okay, around 13 and 32. Okay, so let's check if it is also displaying in our LCD. Oh, so far. Okay, so actually it's also displaying here. Okay, so we're gonna minimize. Okay, so 13. So it's registering here 13. Okay, so our serial monitor as well as the LCD is registering the same. Okay, so better if we're going to choose integer rather than the floating point. Okay, so if you want to use the the fourth pin, actually it's connected to AO and A1. Okay, so it's connected to AO and A1 for the four terminal pin. So let's check the okay, so it's here connected to AO. The green is actually no, the trigger must be the A1. Okay, so and A0. So it's a wrong connection. So this must be A1 and A0. Okay, so let's start simulation. Okay, so we are now registering 81 centimeter, then 32 inches, round off. Let's try to uh, click this one if it is correct. Yeah, it's 32 and 82. Okay, so might as well zoom it back to its original. Okay, So take note, the serial monitor is very important, no, in during an actual sensing of the distance, because it would take a while for you to construct the LCD display. But the serial monitor is built in even in the Arduino program or software. Bye bye.